Okay. Mm. I hope we can be able to see my window journal. Remember, like I said, immediately when I open the window journal, I can't see your messages or your questions. So I'm advising you, if you have any question, to unmute your mic and then raise your question. But please try to behave in that regard. Okay, now we can start now. We are on lecture 6, and then we are on lecture 6. And then it's about the random walk. For those who are having the lecture notes close to them, please open page 25, 3.4, random walk. The question is, what is a random walk? Random walk, is it walking randomly? No. A random walk is defined by this. Let's say you have got a ZT with a white noise of 0 mean and the variance of sigma squared Z. And T is greater or equal to 1. So if ZT has a white noise with mean 0 and variance sigma squared Z, and T is greater or equal to 1, then the process X1 can be defined by Z1. Okay, and X2 will be equal to Z1 plus Z2. Okay, so X3 will be equal to Z1 plus Z2 plus Z3. So if you can just go like that, so our XT will be equal to what? Z1 plus Z2 plus Z3 plus Z what? T. So if it's like that, so this one, the last expression or the last process, which is xt equal to z1 plus z2 plus z3 plus up to zt, can also be written as the summation of I starting from 1 zi up to t. So xt can also be written as the summation of zi, where I starting from 1 up to t. So immediately when you have that expression, so that process now, then the process xt is called a random walk. Okay. If ZT has a white noise with mean 0 and variance sigma squared Z, and T is greater than or equal to 1, where X1 equal to Z1, X2 equal to Z1 plus Z2, X3 is equal to Z1 plus Z2 plus Z3, up to Xt equal to Z1 plus Z2 plus Z3 plus up to Zt. Therefore, the process Xt is called a random walk. Are we together? And it must be noted that a random walk is always non-stationary. Okay? A random walk is always non-stationary. So we can prove that. Show that indeed the random walk is non-stationary. How do we do that? Remember, when you want to prove whether the process is non-stationary or not, you have to do what? You have to calculate your expected value, the variance, and the covariances. If one depends on t, therefore the process is what? It's not stationary. Are we together? So let's try to do that. Let's go to the next page. Remember, a random walk is defined by zt, which is equal to z1 plus z2 plus z3 plus up to zt. That is a random walk. So we just want to prove that this random walk is not stationary, because they said the random walk is always not stationary. Where do we start? We start with the expected value. So expected value of, sorry, it's xt not, yeah, it's xt not zt. Yeah, xt equal to z1 plus z2 plus z3 up to zt. So the expected value of xt is equal to the expected value of z1 plus z2 plus z3 plus zt. Are we together? Can anyone respond to show that indeed you are with me, because you are so quiet?
Sir, we're with you.
Yes, sir.
Okay,
Yes,
thank you
sir.
very much.
In class.
Okay, thank you very much. So
Thank you.
you started with the expected value, which is equal to that. Who can tell me what is the expected value of z1 plus z2 plus z3 plus up to zt?
0.
So we can again write it like this, but I wanted to just go straight to the answer. But anyway, let me just show you how to do this. Expected value of this, expected value of this, up to expected value of zt. Who can tell me what is the expected value of z1? According to that condition, zt has a white noise with mean 0 and variance sigma squared. Expected value of z1?
It's 0.
I was right.
0. Okay, expected value of z2?
Also 0.
It's 0.
Also 0. So all of them are 0. So the expected value of xt now is what? Is 0, which doesn't depend on t. So therefore, we can continue and calculate the variance of xt. Okay, to check whether indeed it's going to be. Okay. Now let's go to the variance now. The variance of xt, which is equal to the var of z1, z2, z3, and zt. So then you introduce the variance throughout. You have var Z1 var Z2 var ZT. So according to the condition, ZT has a white noise with mean 0 and variance sigma squared. So the variant of Z1 will be equal to what?
Sigma squared Z.
Sigma squared Z. The same applies to the variance of Z2 is sigma squared Z. Var of Z3 is sigma squared. Z3 is sigma squared Z. And var of ZT sigma squared Z. So now the answer is what? The final answer is what? So we have got sigma squared Z plus sigma squared Z plus sigma squared Z. So what is the final answer now? Who can tell me?
T
Var
times
of
sigma
X
I
squared.
think
come again?
N multiplied by sigma squared Z.
N.
T
T of
multiplied by
them, not
sigma.
T of them, T of them. So it's T sigma squared Z because it's T of them. The question is it depending on T or not?
Yes, depending on T.
So it's depending on T. So therefore, because the variance of xt is dependent on T, therefore the process xt is not stationary. Hence, the random walk is not stationary. So therefore, you prove that indeed a random walk is not stationary. So you don't have to continue with the covariances because now we have already proved that, okay, the variance is not free of T. So it's depending on T. Therefore, the process xt is what? It's not stationary. I think it's clear, isn't it? Okay, now let's go to another process called a random walk with a drift. The previous one was called a random walk. Now we are going to the other process called a random walk with a drift. So the question is, what is a random walk with a drift? Random walk with a drift. Okay. Now, if ZT is a white noise again, with mean 0 and variance sigma squared Z, and again our T is greater or equal to 1. Therefore, our x1 will be equal to theta 0 plus z1, and x2 will be equal to sorry,
So is that theta?
yeah, it's theta 0 plus z1 plus z2. Same applies to x3, will be equal to 3 theta 0 plus z1 plus z2 plus z3. Okay, then you can go like that until you generalize. Xt will be equal to what? T theta 0 plus z1 plus z2 plus up to zt. Therefore, the process xt is called a random walk with a drift. Therefore, the process, let me just write nicely where Therefore, the process xt is called random walk with a drift. Okay. Xt is called a random walk with a drift, where, let me just go to the next page. Xt is called a random walk with a drift, where a real valued constant theta 0 is called a drift. Xt is called a random walk with a drift, where the real valued constant theta 0 is called a drift. And again,
Sir,
yes.
can you go back for 2 seconds?
Okay. So here xt equal to t times theta 0 plus z1 plus z2 plus up to zt. And this process down there, xt is called a random walk with a drift, where this theta 0 is called a real valued constant, and it's also called a what? A drift. Now, random walk with a drift is also non-stationary. Okay? Initially, we've proved that the random walk is not stationary. And again, now this random walk with a drift is not stationary. So you can just prove that. So I just want you to do that as an exercise. Show that a random walk with a drift is not stationary. I think you can do that. You have to calculate the expected value, check whether it's depending on t or not. Calculate the variance, check whether it's depending on t or not. Check the covariance if it's depending on t or not. But if you find one which is depending on t, so therefore the process is not stationary. So just go and do this one for me as an exercise. Any question before we go to another topic? None. Okay. Now let's go to what we called moving average processes. It's on page 26. So in this case, we're going to start with the first order moving average. Then we go to the second order moving average. Then from there we generalize. We go to the Q order moving average, or moving average of order Q. Then from there, when we're done, we just go to the autoregressive processes. Start with the first order autoregressive. then second order autoregressive, then we generalize it as the p order autoregressive. So without any waste of time, let me just go to the next page where I'm going to introduce the moving average process. Moving average. Process. And then we're going to start with the what? With the first order moving average. Sorry. First order moving average. So you can call it first order moving average or moving average of order 1. MA1. It's a first order moving average or moving average of order 1. Okay. So how do you define the first order moving average or moving average of order 1? Let's define it. So a process xt is said to be first order moving average or moving average of order 1 if xt is equal to zt plus theta 1 zt minus 1, where zt has a white noise which means 0 and variance sigma squared z, and a real valued constant theta 1 let me let's say where zt has a white noise and theta 1 a real valued constant. Okay, let me just put it here, and theta 1, it's a mix up. Erase this one, write it nicely, and theta 1 is a real valued constant. Okay, so the first order moving average or moving average of order 1 is defined by this here, xt, which is equal to zt plus theta 1 zt minus 1, where zt is a white noise with mean 0 and variance sigma squared, and a theta 1 is a real valued constant. Okay, that's the first order moving average. Okay, and what we have to know about the moving average is that moving average processes are always stationary. Okay, moving average processes are always stationary. However, they are not always invertible. So to check whether the moving average is invertible or not, there are conditions that you have to follow, or to check whether indeed that process is invertible or not. Okay, let's consider this first order moving average. Consider that first order moving average xt equal to zt plus theta 1 zt minus 1. Okay, and remember zt is a white noise. Okay, so now, as I said, the moving average processes are always stationary. So, but we have to prove the invertibility. So let's come with the invertible conditions now. Invertible condition. So here we are going to have only one condition because we have only one parameter. And the parameter that we're talking about is theta 1. So we're going to have one condition. For the process xt to be invertible, the absolute value of theta 1 must always be less than 1. Are we together? We have one condition that we have to prove in order to check whether that process is invertible. So for the process xt to be invertible, the absolute value of theta 1 must be less than 1. Okay. So if you don't want to use that condition to check whether that process is invertible, you can use this other method here. So before you use that method, you have to write your process in backshift operator. Still remember what is a backshift operator. So you write that process xt equal to zt plus theta 1 zt minus 1 in backshift operator. So let's write it in backshift operator. So you're going to have xt equal to 1 plus theta 1b zt. So we wrote xt equal to zt plus theta 1 zt minus 1 in backshift operator, which is equal to xt equal to 1 plus theta 1b zt. That is a backshift operator. After doing that, we take everything within the brackets, okay, and equate it to 0. So you take everything within the brackets, which is 1 plus theta 1b, then you equate it to 0 and solve for b. So then this implies that 1 plus theta 1b will be equal to 0. Okay, then we solve for b. So therefore our b will be equal to what? Minus 1 over theta 1, isn't it? It's correct, isn't it? So b is equal to minus 1 over theta 1. Now the question is this value for b outside a unit cycle or not? So this one. After doing this, we check whether this value is outside a unit cycle. If that value is outside a unit cycle, therefore the process xt is a what? Is invertible. So the question is, what is the unit cycle? A unit cycle is a circle like this, where you have a Cartesian plane like this, where here it's 1, here it's 1, here it's minus 1, and here it's minus 1. Okay, that is a unit cycle, this one. So we just want to check whether this value for B is outside a unit circle or not. If it's outside a unit circle, therefore the process xt is invertible. If it's not outside a unit circle, so the process xt is not what? Invertible. So let me show you. When we talk about outside a unit circle, if this value of B here is outside a unit circle, so that means it's here, somewhere here. That is outside a unit circle here. If that value is somewhere outside here, therefore that process is what? It's invertible. Rather, if it's inside, if it's inside the unit circle, somewhere here inside here, so the process is not invertible. And again, if it's on the circle, somewhere there, it's on the circle, therefore the process is not what? It's not invertible. The process to be invertible, the value of B, this one, must be totally outside a unit circle, must be outside. If it's inside or on the circle, therefore the process xt is not invertible. I think it's clear, isn't it? So it's up to you whether you use the first method for invertible condition. Check whether your theta 1, absolute value of theta 1 is less than 1. Therefore, if absolute value of theta 1 is less than 1, is outside, it's less than 1, so therefore the process is what? Is invertible. However, if you want to use the second method, so you write your process in backshift operator. From there, you equate it to 0, then you find the root or the factor of B. Then after finding that value of B, you check for unit circle whether it's outside the unit circle or not. Yes.
So can you please explain again when the process is invertible or not?
Which condition? Because which form? Which one? Which method? Sorry, which method? Because there are two methods here.
The second method.
The second one. Okay, if you
Yes.
want to use the second method, you have a process xt there, which is xt equal to zt plus theta 1 zt minus 1. So after getting that process, you write it in backshift operator, which I did here. Then after writing it in backshift operator, then you take whatever within the brackets, okay, which is this one. Then you equate it to 0. What do you want to do? You want to solve for B. You want to find the root of B, like what we did here. Then after finding that root, you check the value of B, whether is it outside the unit circle or not. If it's outside a unit circle, where are indicated by red arrows, therefore the process is invertible. However, if the root or the value of B is inside the unit circle, what I've indicated by the black arrows there, so therefore the process is not invertible. And again, if the value of B is on the circle, where I indicated by those dots, red dots there, so therefore the process is not invertible. The process to be invertible, the value of B must be outside a unit circle. I think it's clear.
Thank you, sir.
Okay, now let's proceed now. Like I said the moving average processes are always stationary. So if the moving average processes are always stationary, we are allowed to calculate the autocovariances and autocorrelation functions. So now let's calculate the autocorrelation function. Let me just go to the next page. We just want to calculate the autocovariances and autocorrelation functions for moving average of order 1 because it's stationary. So now let's start here, finding A, C, V, F for moving average of order 1. And moving average of order 1 is defined by what? Xt equal to Zt plus theta 1 Zt minus 1. ACVF stands for autocovariance function. For MA1 is a moving average of order 1, which is defined by that process, Xt equal to Zt plus theta 1, Zt minus 1.
Sir,
Yes.
theta 1, is there a way to find it, or they will give us?
Come again.
Will we be given the value of theta 1, or we are going to calculate it?
Yes. This one is a general. It's a general process. There will be a case where I will be giving you a real number, 2, 3, half, quarter, and so on. But sometimes I can just give you these parameters theta 1. You have to be able to know what to do if there is a parameter, and you must know what to do if there is a number. But the procedures are the same. So we are going to just take maybe one example where we are going to use the numbers so that you can see how do we do that. Are you covered?
Yes, sir.
Okay, now let's start. What is the autocovariance function? Autocovariance functions is defined by gamma k, which is equal to the curve of xt minus k or plus k. That is the autocovariance functions. And remember, your k stands for 0, 1, 2, and so on. K can be 0, K can be 1, 2, and so on. If K is 0, so you're talking about gamma 0. K equals 1, you're talking about gamma 1. K equals 2, gamma 2, and so on. So what we are going to calculate here, we are going to calculate gamma 0, gamma 1, gamma 2, gamma 3, and so on.
Sir,
Come again.
is it T minus K or T plus K?
Yes, you can use T plus K or T minus K. It's the same thing. You're going to get the same answer. You still remember the properties of the covariances, where I said gamma K is equal to gamma of minus K. You can use gamma K or gamma of minus K. It's the same thing.
Okay.
So in this regard, we just choose to use Zt minus K instead of Zt plus Zt xt minus K instead of Z xt plus K. So it's the same thing. Okay, now let's start. Let's start by finding the expected value of xt. So the expected value of xt will be equal to the expected value of zt plus theta 1 zt minus 1. Obvious, this one is equal to 0 because zt is a white noise, which means 0, and variance sigma squared z. So obvious, expected value of xt equal to 0. So now comes to var of xt. Var of xt will be equal to the var of zt plus theta 1 zt minus 1, isn't it? Now you can introduce the variance throughout. So you're going to have what? Var of zt plus what? Who can tell me? Var of theta 1 zt minus 1 is equal to what?
Theta squared, the var of zt minus 1.
Yes, which is theta 1 squared var of zt minus 1. That's it. Then what is the var of zt? Var of zt according to that condition is going to be sigma squared z plus theta 1 squared. Var of zt minus 1 again is sigma squared z. So the question is, what is sigma squared z plus theta 1 squared sigma squared z equal to? So will be equal to what? 1 plus theta 1 squared sigma squared z. So therefore, the var of xt equal to 1 plus theta 1 squared times sigma squared z. And remember, according to the properties of autocovariances, var of xt is always equal to what? Gamma 0. Okay. So gamma 0 is equal to 1 plus theta 1 squared times sigma squared z. So now we've already started finding gamma 0. So you have to continue to find gamma 1, gamma 2, and so on. But before you do that, there is another method of finding gamma 0. So let me show you another method of finding gamma 0 if you don't want to use that one for var of xt. Can I go to the second? There is somebody who didn't mute the mic there. Please mute your mic. Okay, thank you very much. Okay, gamma 0 is equal to open brackets 1 plus theta 1 squared times sigma squared z. So now let's find another method of finding gamma 0 if you don't want to use that one for var of xt. So gamma 0 again is equal to the curve of xt. You know where is it coming from? Let's go back. Gamma k is equal to this curve of xt minus k. But if k equal to 0, here you're going to get gamma 0. Here you're going to get xt. Here you're going to get xt. So that is why we're using what? Gamma 0 equal to curve of xt. Okay. Which is equal to what? Curve of, what is xt? Xt is equal to zt plus theta 1 zt minus 1. Okay. What is xt again? Zt plus theta 1 zt minus 1. Okay. Now we are having this now in terms of curve, which is equal to what? So we take z and zt and theta 1 zt minus 1, theta 1 zt minus 1, and zt. So you're going to have what? The curve of zt and zt. Then you said plus. You take zt and theta 1 zt minus 1. You're going to have theta.
Can you explain again
What?
the current step?
The one that third one.
Yeah.
Okay. Let me just do it so that you can understand it better. I'm saying here you take this one, okay, and this one,
Sir.
combine them together. Yes.
Sir,
Yes.
can you please explain from the beginning?
Beginning of
Okay.
what? From random walk.
From gamma.
Gamma
No,
what?
the first step.
It means the
On the
first step.
same page.
Yeah.
On
Gamma
the same
0.
page. Oh, okay. Thank you.
Yes.
Okay, it's fine. So I'm saying, let's go a little bit back so that we understand. I said we calculated gamma 0, which is equal to var of xt. Var of xt, which is equal to 1 plus theta 1 squared sigma squared z. I said, if you don't want to use this step, the last step here, for finding gamma 0, so you can use this one. Gamma 0 equal to the curve of xt. Remember the previous way of finding gamma 0, we were using var of x. We said gamma 0 is equal to var of x, then you calculated var of x, xt. So in this time around, we are using gamma 0. We are finding gamma 0 using the covariance of xt and xt. So where is it coming from? Xt and xt. I said it's coming from gamma k. If you check gamma k here, it's equal to curve of xt minus k. So if k is equal to 0, gamma k now becomes gamma 0, which is equal to the curve of xt, comma, xt minus k now becomes xt. So you are going to have curve xt, which is what we are having here on step number 1. So now, how do we calculate the curve of xt and xt? Step number 2. Curve of xt is equal to zt plus theta 1 zt minus 1. Okay? Instead of xt, we replace it by what? By zt plus theta 1 zt minus 1. We do the same for the next xt, zt plus theta 1 zt minus 1. So step number 3. Step number 3, you supposed to find the covariance of everything which is here. So where do we start? We start with combining zt and zt. When you combine zt and zt, you are going to get the curve of zt and zt. Then you said plus. You combine zt again with what? Theta 1 zt minus 1. Find the covariance of that. Then you get what? Because theta 1 is a constant, take it out as a constant. Theta 1, then curve of zt minus 1. Okay. You see it. Then you combine what? Theta 1 zt minus 1 with zt. Find the covariance of that. You get what? You get theta 1 because theta 1 is a constant. Then the covariance of what? Of zt, theta 1, zt minus 1. Okay? You proceed. And do what? And combine this one. With what? With this one. Find the covariance of that. Then you get what? Plus. Because you have got two constants here, theta 1 and theta 1. So you multiply them together to becomes what? Theta 1 squared. Then curve of what? Zt minus 1, zt minus 1. Are we together?
Yes.
Okay, now let's
Sir.
continue to the next step.
No, so,
Sir.
sir, I'm lost. Can you repeat step number 2?
So I'm also lost.
Sir,
From where?
why?
One person at a time, please.
Say,
Yeah.
where did you say theta 1, the curve of the zt minus 1? Then again, we have theta 1, curve of theta 1, zt minus 1.
Okay. Let me explain it. You mean this one, isn't it? This one. What is happening here? I said you combine zt. You combine zt. Okay. With theta 1 zt minus 1. You get that one? If you find the covariance of that, remember theta 1 is a constant. That is why I take it out here as a constant. Then I combine zt minus 1 and zt, which is this one, and find the covariance of that. This is what I did here. Okay, so the next one, because ZT has to be combined with ZT, and ZT again has to be combined with theta 1 ZT minus 1. So you come to theta 1 ZT minus 1, which is this one. You combine again with what? With ZT. Okay? Then theta 1 is a constant. That is why it's outside here. Then you put curve, which is this one. Then you take ZT. It's the same. You can just start with ZT minus 1. ZT is the same thing, as long as if you are multiplying. Or you can start with ZT, then write this one.
Sir.
So in my case, I started with ZT and then ZT minus 1. This is what I got.
Say, the constant which is theta 1 there, where did it come from? Because here it's theta 1 ZT minus 1 and ZT.
From which? From this type?
First, it
No,
also
the other one.
This one?
if they can use
Yes.
What?
If they can try it by using the
Okay,
expectation, expanding what is inside the
you are
curve
referring
and
to this one.
distribute the
You are referring to this
expectation.
one, isn't it?
Yes, sir.
Oh, yes, you are right there. Because I included theta 1 twice here. So, and we're dealing with what? This one and this one, isn't it? This one and this one. So it's theta 1 outside, then Z. Yes, this one, thank you very much for that. This one's supposed to fell out, go away. Yeah, thank you for that. Any question? So it's this one. Let me see, check this one. Wait. Let's start from the beginning, because now it's too. You can't see what is happening here. Let me go back to this step so that you won't get confused. You have to get this right so that you can continue. Okay, let me start from scratch so that you can understand this one. I'm saying here we are taking ZT and ZT, isn't it? So it's the curve of ZT and ZT. Okay. Then you take ZT and theta 1 ZT minus 1. So you're going to have plus theta 1, the curve of ZT and ZT minus 1, isn't it? Then you take theta 1, this one, and this one. So you're going to have plus theta 1, the curve of ZT minus 1. Minus 1, yes. Okay, which is this one. Again, then you take the last one, theta 1 ZT and theta 1 ZT. So it's theta 1 squared, the curve of ZT minus 1, ZT minus 1. Are we together?
Yes, sir.
Yes. So now from there, you check those that are independent. If the two variables are independent, so their covariance is 0, isn't it? So the curve of ZT and ZT, so here you're going to get what? It's like this one, it's like the var of ZT. Curve of ZT and ZT is like the var of ZT. And the var of ZT is sigma squared Z. So therefore here you're going to have sigma squared Z. Sigma squared Z plus. It's for this one. Then coming to this one are independent, ZT and ZT minus 1. So their covariance is 0. So obviously this one is going to give you 0. The same applies to this one. This one and this one, they are independent. So their covariance is 0. So you're going to get 0. So coming to this one, so you're going to have theta 1 squared, sigma squared Z. Are we still together?
Yes, sir.
Okay. Which is equal to what? 1 plus theta 1 squared sigma squared z, which is the same as what we've calculated before, if you still remember. Which is equal to this one. Okay. So this is equal to the previous one. So what I was saying is that you can use this method or use the previous one where you have to calculate the var. You are going to get the same answer. I think it's clear. Can you move on? Okay. Let me
10
just
minutes.
break.
10 minutes.
Yeah, break, sir.
You're tired. Okay,
Yeah.
let me just.
We are tired break.
We can't think.
Yo,
Can't concentrate. Okay,
I want to
so
drink water.
okay, it's fine. It's fine. Okay. If you want a break, let me just give you a break. We are going to come back at 8:40, isn't it?
Yes.
Okay, fine.
8:42. 10
Take a
minutes.
break.
Yeah.
10 minutes, yes.
8:42.
8:40. 8:40. Okay, you can take a break.
Sir, may you please return the screen, the whiteboard?
Already.
Yes, please.
No. Okay, it's fine.
Thank you, sir.
Okay, we are back. Can we continue?
Yes.
Yeah, we can continue, sir.
Yes.
Okay.
We can continue.
Okay. So we calculated gamma 0. So we have to proceed to gamma 1. So how do you calculate gamma 1? Gamma 1 will be equal to the curve of xt minus 1. That's gamma 1. So which is equivalent to the curve of, what is xt? Zt plus theta 1 zt minus 1. Okay. And xt minus 1, where there is zt, you put zt minus 1. Where there is zt minus 1, you put zt minus 2. Okay. So we're going to have
So
zt minus 1. Yes.
t minus 1 is just like t minus k.
Yes, it's coming from that one. Remember, k, yes, it's the same thing. But we substitute k by what? By 1 to get gamma 1. So that is
Oh,
why here we have got curve of xt and xt minus 1. Because gamma k was the general one. So you do the same. You take zt and zt minus 1, zt theta 1, zt minus 1, theta 1, zt minus 1, and zt minus 1. Then theta 1, z minus 1, and theta 1, z minus 1. You're going to get this one. So I'm going to skip step number 3 and go straight to the answer. Because some of these are independent, so their covariance is 0. So the final answer here will be, what is happening here? Yes, zt minus 2, sorry. Yeah, zt minus 2, not zt minus 1. Okay, it's fine. So we are going to take only these two, combine them together. The rest are zeros. So therefore we are going to have what? Theta 1, the curve of zt minus 1, zt minus 1. Are we together? And this is equivalent to what? To theta 1 sigma squared z. So therefore gamma 1 is equal to theta 1 sigma squared z. Then you proceed to gamma 2. So gamma 2 will be equal to the curve of xt.
sir,
Yes, xt minus
can you
2.
please explain the previous step before you go to gamma 2?
I said for the previous step, I said I'm going to skip another step. If you still remember here, let me just go back again here. Yeah, you see this step here, this one. This is the one that I have skipped there because it's too long. Some of them are, the covariances are zeros, so I left them out. Okay, so that is why I didn't have this step here. Yeah, I didn't have that step. It was supposed to be here.
Okay.
So there are those that their covariances, because they are independent, are zeros. So that is why I combine only two, theta 1, zt minus 1, and zt minus 1. Because the rest are zeros. And get that one. So gamma 2 is equal to curve of xt minus 2. So which is equivalent to what? The curve of, what is xt? Xt is zt plus
Sir,
theta 1. Yeah.
sir,
Yeah.
step number 2 on the term number 3, is it z t minus z or t minus 2?
You mean this one? This
No,
one.
step number 2.
This one.
Which one?
You mean
Yes.
the last? This one. You're
Yes.
referring to this one.
The last term.
Yes, this is ZT minus 2.
Okay. Thank you.
So gamma 2 is equal to the curve of ZT plus theta 1 ZT minus 1 and what? ZT minus 2 plus theta 1 ZT minus 3. See now. So in this case, if you check whatever variable you are going to combine together, they are going to give you the covariance which is 0. So at the end of the day, gamma 2 is going to be equal to 0. Okay? So you can combine ZT and ZT minus 2, or combine ZT and ZT theta 1 ZT minus 3. Their covariance is 0. You combine theta 1 ZT minus 1 and ZT minus 2, covariance is 0. You combine theta 1 ZT minus 1 and theta 1 ZT minus 3, their covariance is 0. So gamma 2 will be equal to 0. Okay. The same applies to gamma 3. Let me just go to the next one. Same applies to gamma 3, which is equal to the curve of xt minus 3. You are going to get 0. Gamma 4, 0. Gamma 5, 0. Until you generalize it as gamma k. So gamma k, which is equal to the curve of xt minus k, will be equal to, now we are generalizing everything, okay? If you check, your gamma 0 was 1 plus theta 1 squared sigma squared z for k equal to 0. If k equal to 0, so you have got gamma 0. So gamma 0 is equal to 1 plus theta 1 squared sigma squared z. And gamma 1 is equal to what? Theta 1 sigma squared z, isn't it? For k equal to 1. That's gamma 1. Gamma 2 is 0. Gamma 3 is 0. 4 and 5 and so on. They are 0. So therefore, is 0 for k greater or equal to 2. So this is the whole of this. Let me show you the whole of this. Now, this is the autocovariance function. This is what we've been looking for. This is the autocovariance function. It's the autocovariance function of moving average of order 1 is equal to 1 plus theta 1 squared multiplied by sigma squared for k equal to 0, theta 1 sigma squared z for k equal to 1, and 0 otherwise. That is the autocovariance functions altogether. Any question before proceed? None. So this is how you calculate the autocovariance function. This is the method for calculating the autocovariance functions. Can I give you another method if you don't like this one, or if this one is too long for you?
Yes, please.
Yeah,
I don't know if
this
Another one.
okay, let me just give you another one. Method number 2. Okay. Okay, let me start from scratch. Xt is equal to zt plus theta 1 zt minus 1. This is the moving average of order 1. Okay. So now, from here, you have to write this process in backshift operator. And we did it if you still recall, 1 plus theta 1b, then zt. So this is backshift operator. Now the method number 2 that I want to introduce to you is this one. You use gamma b, which is equal to psi b, psi b inverse. Then you multiply it by sigma squared z. So this method, we call it autocovariance generating function method. It's called autocovariance. Let me just write it here. Sorry for that, so that I won't confuse you. Let me write it here. It's autocovariance generating method. So this is the method that we use to calculate the autocovariances. Autocovariance generating method for calculating
Sir,
autocovariance functions. Yes.
so what is the name of the first method?
The first method is just to calculate the autocovariances. You don't have the name for it. It's to find gamma 0, gamma 1, gamma. We don't have the name for that one. So this one is called the autocovariance generating method. If I said calculate the autocovariance functions using autocovariance generating method, you have to use the method number 2, the one that I've introduced. If you use the previous one, now you get 0. You didn't get the instruction. So it's very important to know this method as well, because I might say calculate the autocovariances using autocovariance generating method.
So
you have
we
to
have
use
to know all of them.
Yeah, that one, yeah, it's a must.
Yeah.
Or maybe to be on the safe side, you can just ignore the first one, method number 1, because that one, there's no name for that method. But this one, I can just say find the autocovariances using autocovariance generating method. So this is the method that I want you to know. But you can just,
Okay.
if I didn't highlight or say use which method, you can use any method.
Yeah, we'll just use this one since we have to know it.
But you don't know how difficult it is. Okay, let's just go to it. Okay, I said the first thing to do is to write the process in backshift operator, okay, which we did. Then from there, you introduce that gamma B, which is the autocovariance generating method. So then from there, you do it like this. Step number 2, psi B is equal to everything within the brackets, okay? It's psi B. 1 plus theta 1b, okay? That is your psi B. Psi B inverse is everything within the brackets, but with B inverse. So in other words, like this, 1 plus theta 1b inverse. Then you multiply by what? Sigma squared z. Do you follow?
Sir, are those absolute values or they're just brackets?
Those are the bigger brackets.
Oh,
This one. This one.
all right.
Now, step number 3 is to open the bracket.
Second,
Simplify.
explain the current.
Step number 3 is to simplify. Open the brackets. In other words, take 1 multiplied by 1, 1 multiplied by theta 1 b inverse. Is there anyone talking?
Can you please explain the step?
Which one?
Step number
I can't
2.
get. step number 2. I said
Yes.
from step number 2, to get the psi B, to get this one, you take everything within the brackets, that is this one, and put it here. So it's what I did. To get this one, you take everything within the brackets, but where there is B, you put B inverse. That is what I did. Then you close the brackets. Then you multiply by sigma squared Z. So now from there you open the brackets, simplify. So 1 times 1 is 1 plus 1 times theta 1 B inverse is theta 1 B inverse. Theta 1 B times 1 is theta 1 B. Theta 1 B times theta 1 B inverse is theta 1 squared. Then you close the brackets. We're still together. From there, you group those that are constant, that doesn't contain B's. Group them together. So when you group them together, can I go to the next page, please?
Yes, sir.
So gamma B is equal to 1 plus theta 1 squared. We group them together. This one. We take this one because they are constant. They are constant, this one. Okay? Group them together. It becomes what? 1 plus theta 1 squared. Then you said plus. If you check here, you can find the common factor, isn't it? Which is theta 1. So get the common factor there, which is theta 1 B inverse plus B. Then you multiply by what? Sigma squared Z. This is what I did. Do you follow?
Yeah, we follow, sir.
Okay. Now,
No, sir. Sorry.
what's the problem?
So may you please go back to the previous step until this point, because like I'm confused.
Oh, from which step? Step number?
Yes, the last step. From this last step after you distributed and then to the next page.
Okay. I have to start explaining from this step.
Number 3.
Number 3. Okay, it's fine.
Yes.
Okay. How did we get the third step here? We just simplify step number 2.
Yes.
Okay. We multiply 1 by 1, we get 1 here. 1 multiplied by theta 1 B inverse, we get this one. Theta 1 B multiplied by 1, we get this one. Theta 1 B multiplied by theta 1 B inverse, we get this one. You get it?
Yes,
Then
sir.
from there, the next one, you group those that are constant together. So in other words, the constant is 1 and the theta 1 squared. Group them together. This is what we did. Group them together. Then the next one, this to get this one, we find the common factor. If you check here, it's theta 1 B inverse plus theta 1 B. So the common factor is what? It's theta 1, then open brackets B inverse plus B. So this is what we did. This is what we've done.
Okay, thank you,
Then,
sir.
okay. While you are there, so you find your answers. You are done. So this one, which is a constant, okay, or maybe you can just multiply through by sigma squared Z. Let's continue to another step, the last one, I think, so that you can see it nicely. So this is equal to 1 plus theta 1 squared, then you multiply by sigma squared Z. You're going to get what? 1 plus theta 1 squared, sigma squared Z. Okay. plus theta 1 times sigma squared z. You are going to get what? Theta 1 sigma squared z multiplied by what? Beta inverse, B inverse, sorry, plus B. You follow? So now, you're done now. So this, the whole of this, we call it gamma 0. Because they are constant, they are called gamma 0. And this one, because they are having B inverse and B, we call them gamma 1. Okay. So here we were supposed to have maybe B to the power minus 2 and B. But we don't have, there is nothing here. So there is nothing there. So therefore, here you can have gamma 2, which is 0, because there is
Sir,
nothing there.
what are the
Yes?
reasons again?
Eh?
What are your reasons? Can you
For
repeat
what?
the reasons for
For
gamma 0, gamma 1,
gamma
and gamma
0, yes. Reason for gamma 0. Why am I saying that this one is gamma 0? Because it's constant. Doesn't depend on B inverse and so on. So it's constant, this one. That's why you call it gamma 0. So this one, we call them gamma 1 because there is a B inverse plus B. So that is why we call it gamma 1. So for gamma 2, you're supposed to have a value there together with what? B to the power minus 2 and B squared. But we don't have them there. So gamma 2 is what? It's 0. For gamma 3, we were supposed to have a value together with B to the power minus 3 and B cubed. But in this case, we don't have it. So therefore, gamma 3 is 0. The same applies to gamma 4, 5, and so on. They are zeros. So the final answer now becomes, I can erase these ones, isn't it? Because I was just explaining. Let me just erase this one. So the final answer now becomes what? Gamma k equal to, you can say curve of xt minus k, which is equal to, okay, for gamma 0, you have got 1 plus theta 1 squared multiplied by what? Sigma squared z. That's gamma 0. Okay, for gamma 1, you've got theta 1 sigma squared z. That you are k equal to 1. The rest are zeros. The rest are zeros. So which is the same as what we did on the previous page. So this is how to calculate autocovariances using autocovariance generating function method. So if you want to check, you can check it. They're the same with this one. You see, they're the same with this one. Just because here, instead of writing 0 for greater or equal to 2, I wrote 0. Otherwise, it's the same thing. So it simply means that is 0 for others. So it's the same thing. It's either you write 0 otherwise or 0 greater or equal to 2. Or you write 0 for k greater than 1. So it's the same thing. Any question before we proceed?
Sir,
Yes.
what is that b plus b to the power of 1? Is it a constant?
That one. Hey, it's a constant. It
Sir,
will always be there. You can't say it's a constant.
sir,
Yeah. Yes. Go on. Yes, I gave you the opportunity. Just ask your question. Seems as it's gone, so she will come back. Any question before proceed? Okay. Guys, are you still there? Because it's quiet.
Yeah.
Okay, it's fine. Yeah, so quiet. I thought maybe I'm alone now.
Oh,
Okay. Now we have calculated the autocovariances. Now we just want to calculate what? The autocorrelation functions. Now we have to calculate the autocorrelation function for the moving average of order 1, which is xt equal to zt theta 1 zt minus 1. So we have calculated the autocovariances. Now we just want to calculate the autocorrelation functions. So this one is very simple. Immediately after getting the autocovariances, it's simple to get autocorrelations functions. Now where do we start? Start with the general one. Rho k is always equal to gamma k over gamma 0. From the properties of autocorrelation functions, rho k equal to gamma k over gamma 0. So now we just want to find rho 0, rho 1, rho 2, rho 3, and so on. So rho 0, according to the properties, I said it's always equal to 1. But if you don't want to just put a 1, you can just define it as gamma 0 over gamma 0. So it's 1. Okay. Rho 1.
Say you are saying rho 0 is always equal to 1.
Yeah, according to the properties. I think I have introduced that one before.
Yeah.
So you don't have to calculate that one. You must know that rho 0 is always equal to 1.
No, all right, sir.
So rho 1 is equal to gamma 1 over gamma 0. So the question is, what is gamma 1? Gamma 1, if you still recall, is theta 1 sigma squared z divided by. So gamma 0, it's 1 plus theta 1 squared multiplied by sigma squared z. So this to the sea, this to the ocean. Now we are left with what? Theta 1 over 1 plus theta 1 squared. So this is rho 1. So rho 1 is equal to theta 1 over 1 plus theta 1 squared. Now together. So then we proceed to rho 2. Rho 2 by definition is gamma 2 over gamma 0. And remember, gamma 2 is 0. So 0 over gamma 0 is going to give you 0. The same applies to rho 3 is 0, rho 4 is 0, until you generalize it to gamma k. Okay. So we can generalize it now. So gamma k, which is equal to the core. I said the core before. Oh, it's a formula. The core of xt minus k is equal to.
Sir,
Yes.
what did you say rho 2 is equals to?
I said rho 2 is equal to gamma 2 over gamma 0. And remember, autocovariance functions of order 2 is equal to 0. So this leads us to rho 2 to be equal to 0.
Okay, thank you.
Okay. So now we are generalizing. So we have got 1 for k equal to 0. And then what? Theta 1 over 1 plus theta 1 squared for k equal to 1, isn't it? And 0 otherwise. So this is the autocorrelation functions of the moving average of order 1. Any question? I think our time is up. We can stop here. But if you have a question, you can ask it before we go.
We don't have an example.
We're going to do the example next time. Because we need the numbers, isn't it? Instead of using parameters, we're going to use the real numbers next time. Because we don't have time now. Our time is up. I was supposed to introduce the one that involves real numbers. But because our time is up, we won't have that. We're going to do it next time.
When are the tutorials?
On Wednesday next week.
All right.
Yeah. Any question? None. Okay. We can stop here. Thank you very much for participating. See you next time.
Sure. Our floor
Bye.
questions.